Look at thermochemistry. Thermochemistry, it simply means a study where we should be dealing with energy changes accompanying a chemical reaction. Now we should put in mind that during a chemical reaction, there will be energy being absorbed, which is to be used to break the bonds between the atoms, and energy will be given out when new bonds are formed. You should put in mind that new bonds are formed within products, and the bonds that are broken are always in reactants. So in thermochemistry, we shall be looking at the heat change that will accompany a chemical reaction. So we shall have basically two types of chemical reactions. That is, in the thermical reactions, we shall have reactions that gain heat in case they take place. Then we shall also have exothermic reactions, whereby, for example, you can see this is carbon burning. As it is burning, it will produce heat, which heat is the energy. So it means exothermic reaction produce heat to the surrounding. Then endothermic reactions gain heat from surrounding. Endothermic reactions, as I told you, they proceed with absorption of heat from the surroundings. Then the products, this is potential energy, and this is reaction coordinate. Then we shall see that reactants are found at a lower energy level here down. Then the products are at a high energy level. Then the change between the enthalpy change between the products and the reactants, this is what we call a positive enthalpy, which signifies endothermic reaction. And this a highly energetic complex, this is what we call the transition state, or where we have the activated complex, and this will be activation energy. We shall look at activation energy in chemical kinetics, but this is the transition state whereby the activated complex is converted into the product. So we shall basically have, during endothermic reaction, we shall know that heat is always gained from the surrounding. Therefore, the products will have a high heat content and reactants will have a low heat content. And the difference between the heat content of the products and that of the reactants, we shall have a positive sign. Let's look at examples where we have endothermic reactions. So we have dissolution of ammonium nitrate in water. Then we shall also have photosynthesis, among others. We shall know that in photosynthesis, that for it to take place, we shall need sun to supply the light and the heat, which heat is required to activate the enzymes. Exothermic reactions, for them, they evolve heat or they produce heat to the surroundings, and the products, these are the products, they are found at a lower heat content, and the reactants are at a high heat content, and the difference is what gives us a negative sign on our enthalpy, which means in the exothermic reactions, for them, the heat change accompanying that reaction is a negative heat value. For example, if you have ever cooked, you realize that the charcoal or the carbon you use or the gas you use or anything you heat, you burn something to produce heat, which heat will be absorbed now by either a saucepan or by any cooking vessel. You realize that heat is produced. Examples, we have dissolution of sulfuric acid in water. Then we shall have combustion. In case you burn a paper, you realize that the temperature around will increase.